Okay, thank you for having me. I'm Junchang from Nanjing University of Postage and Telecommunications, and this is a joint work with Manois from Boston University. So a quick introduction to bitmap indexes. So in the basic form, a bitmap index represents the contents of the index column by using multiple bit vectors. So in this example, we have a column A with 3 unique values. So the associated bit vector will have 3, associated bitmap will have 3 bit vectors, and each bit vector corresponds to 1 unique value. Bitmap indexing is useful, in particular for analytical workloads. The fundamental reason is that the query result is readily available, and more importantly, in a compact manner. So, for example, once a point query arrives, we can simply pick 1 bit vector and just return the bit vector as the result. So it's super fast for analytical workloads. However, bitmap indexes do have limitations. In particular, to reduce its size, we typically will have to use some variations of run length encoding to compress each bit vector. But the challenge is that after compression, the bit vector will become very expensive to change. Even if you want to flip a single bit in the compressed bit vector, you typically must decompress the bit vector first, and then flip the bit, and then recompress it. So this is what we call decode, flip, and then encode procedure, which is very expensive in practice. So bitmap indexes traditionally only used for read-only use cases. So that's the motivation. And for this work, Qubit, what we want to do is to make bitmap indexes update friendly, in particular on multi-core systems. Technically speaking, what we did is to provide with-free guarantee for queries. That means queries can always complete, even if there is a heavy update workload. And updates are log-free or latch-free. Basically means they never block each other. Rather, they help each other to complete and provide a system-wide progress guarantee. To achieve that goal, Qubit employs 3 key building blocks. The first is out-of-place update. So specifically in Qubit, rather than directly flipping bits in bit vectors, Qubit will store the update information in a per bitmap log. By using this way, the update will become very lightweight. The second building block is multiversioning, which can help Qubit to separate queries from concurrent updates, such that we can guarantee that queries can always complete in a finite number of steps, even if there is a heavy update workload. The third building block is segmentation, which is explicitly designed for bitmap indexing, such that Qubit can benefit from increasing hardware power. For example, the multi-core and the themed instructions. So one thing we want to note is that all this thing must be done in a very lightweight manner, because indexing have a very limited time budget to execute. So all of this thing must be extremely lightweight. I won't go into details, but you can refer the paper. We integrated Qubit, our latest work, into DuckDB, and that's why we are here. Because qubit is update friendly, that allows us to build qubit instances for attributes in the table that are being updated. For example, as we know, this is the first time that we can build qubit instances for quantity and order keys in the line item table, in the fact table, line item in TBCH benchmark. And then we can run flash operations concurrently. Based on that, because we have qubit instances already built, we implemented qubit-based scan, aggregation, and join executors. They are not traditional executors, for example, relying on hash tables. Rather, they rely on bitmap indexing. Please refer our paper for details. Our evaluation shows that across a variety of queries, qubit-powered query engine can outperform. So our conclusion is not that qubit can outperform DuckDB overall. Rather, our conclusion is that DuckDB indeed make it easy for us to integrate and experiment with new indexing mechanism like qubit. And our evaluation with DuckDB shows that qubit or bitmap index can not only accelerate the scan, but also aggregation and join operations. Even though qubit has addressed the updatability issue, it still has limitations, primarily because qubit mainly focus on point queries. And for more common range queries, a lot of development is required. So we are continuously working on qubit, and qubit for range queries is our next work, which will appear in SIGMOD next year. So overall, qubit is a novel, update-friendly bitmap indexing mechanism, and DuckDB allows us to easily integrate this novel indexing mechanism into it, and experiment with a lot of new features. So we really appreciate DuckDB. We are still actively working on this direction, and our goal is to provide a new type of general secondary index based on bitmap. And if you are interested, please contact us. Thank you.
Thank you.